There we are, AP Stats. What is going on? This is Coach Jay. I just wanted to quickly provide hopefully some help in regards to ways that you could execute the FRQs. Again, make sure you provide some evidence in terms of how you missed the FRQs, and make sure you go through that even today as we have this due tomorrow by midnight. What I'd like to do real quick is just identify with I'm going to scroll up here, and I'll actually start on number 1 and just kind of go through with you what we're looking for. The first thing it says use the same scale to draw box plots. A couple things that we want to make sure we note that a lot of you missed. First of all, the same scale, that's a big issue. Some of you had 2 separate ones when in reality we should have had the same scale here once we graphed it. The next thing a lot of you missed was providing evidence concerning the so we have students, making sure we label. So students might be here and faculty might be on this side. Understand too that this is completion time in minutes. Completion time in minutes. Making sure you label that appropriately, and then also like scaling it going forward. Hold on just a sec. Let me get something. Sorry about that. I'm getting an exam just so I can kind of see it. So as I look at this, I'm just throwing this out here. The students one was somewhere, and I'm throwing like an estimate out there, a little bit shorter. Whereas the faculty moved a little bit towards the right-hand side, okay? Something like this. So then it asks, write a few sentences comparing the variability. Well, this is where we're going to use stocks on this, okay? Specifically comparing the variability. So the one thing that we, and actually I don't even think I need all of stocks because it doesn't say just compare the distributions, but specifically the variability. There were 2 things we had to compare with this variability that you just needed to know. First off, we needed to compare our range, because we didn't know standard deviation. And the second thing we needed to compare was I'm just hitting it. Oh yes, and then IQR, because that is another form of variability as well. Those 2 things needed to be compared. If you had one of 2, then obviously you got a P out of that section, and so that's where we were at there. The next part, hold on, click this, scroll down to C, part C. Part C was, you've been asked to report on this event for the school newspaper. Write a few sentences describing the student-faculty performance in this competition for the paper. Well, first off, I was pretty loose on this, but on the AP exam, they may not be. You've been asked to report on this for the school newspaper. You need to make sure that you write like a reporter. So don't just state stuff, but say something to the effect of, and it doesn't have to be perfect, but like act like a reporter when we talk about, hey, last Friday, the students and faculty squared off to be able to, and then go into it, right? Like a reporter. In this situation, when you provide evidence for this, you needed to include S, and really you don't have to say outliers, but either the shape, center, or spread. To get full credit, you needed to compare 2 of 3 here. So when you look up at the top there, comparing the spread, the shape, and the center, you needed to include 2 of 3 to get full credit there in the context of a reporter. Okay? Excellent. Let's go to the next one. Question 2 was a little bit tricky. This one asked, if a doctor treats a child with an ear infection using Plan 1, what is the probability that the child will be cured? Plan 1 stated that we treat with an antibiotic A first, okay? So we're going to do both of these for Plan 1. And so the first thing we do is we go to antibiotic A. Now it has the possibility of curing the infection 60% of the time. So this is either cure or NC, which is not cure. If I cure, that is 0.6, and if I don't cure, that is 0.4. For the cure side of it, if it is cured, it is done, because we don't want to use it. If it is not cured, we're going to actually implement B, which then has the probability of being cured 0.9% of the time. So I'll put C, which is 0.9, and not cured 0.1% or 10% of the time. So when I look at this, notice there's 2, so 0.4 times 0.9 is 0.36 overall, where 0.4 times 0.1 is 0.04 overall. When I add 0.36 plus 0.4 plus 0.6 together, I should get a total of 1. So the question is what is the probability that the child will be cured? Well, the probability that it would not be cured is 0.04. So it's really 0.6 plus 0.36. 0.6 plus 0.36, which is equal to 0.96. Now, technically, when I'm writing this, I probably should put something to the effect of the probability of being cured is equal to, like actually writing it out. So 0.6 plus 0.9, or I'm sorry, 0.4 times 0.9, right? And then that would equal 0.96. I would also say that in the context of the AP exam, NC, actually write it out, okay? So not cured, cured, or if you use NC, just say NC is the same as not cured, okay? All right, try the below problem. I will tell you that when you do this, so when you start with antibiotic B and you go to cured or not cured, that this would be a little different, where cured would be 0.9 and not cured would be 0.1. Continue forward with it just like you did here, where you go to A. I know I'm doing the shorthand. Make sure you write this out. Okay, so cured would be 0.6 and not cured would be 0.4. Multiply this to get 0.06 and 0.04. And so, again, doing the same thing out would be 0.96, because 0.9 plus, here's the 3, right, that add to 1, plus 0.06 equal 0.96. But again, still put the context down below here, okay? Good, good. All right, so the next question is, coming down, what is the expected cost per child when Plan 1 is used for treatment? Okay, well, Plan 1 stated, let's see here. Okay, treatment with antibiotic A costs $50. Actually, I want to do this. Let me backtrack. Perfect. Okay, so let me do this in yellow just for a second. And you want to show this down below. So don't, I'm doing this again shorthand. You want to make sure you show this. So antibiotic A, this cost $50, right? $50, okay? So when I cost $50, the expected cost would be 50 times 0.6, right? Because that would be a cure. Plus, if that did not work, I want to make sure I've got this down here. $50 plus 0.6, which should be 30 plus, and then this over here would be 80, is that right? $80. So let me make sure. Compute the expected cost when plan 1 is used for treatment. Well, here's the deal. I'm going to spend $50. Let's do this. Let's start with this. $80 is my end, right? So I could either spend $80 or 50 times 0.6. Hold on just a second. Let me make sure. All right, so as I look at this part here, what I want to look at, and here's what I'm going to do on this section. I'll come back to that. I want to look and see really fast at the 6. Okay, so I would say this. I can either be cured here and I stop, or I can go, if it's not cured, I can add $80 to this, right? So as I look at this, I get 30 plus 80 equals 110, okay? Whereas below, I can pay over here $80, 0.9% of the time, or 90% of the time. So 80.9% of the time. Or I was just double checking myself, add $50, which it doesn't matter whether I'm cured or not cured. Okay. So as I look at this, I would then have 72 plus 50, which is $112 compared to $110. You say, Coach, why is 80 and why is 50 just by itself? Remember that if I'm cured, I don't have to go to antibiotic A. But if I'm not cured, in this instance down below, I would have to go to A and pay $50 additional on that. So the question now becomes, based off the red is 0.96 regardless, and the cost of 110 and 112, which is the better option? Well, that last question is where we go into it down below and we say, okay, well, let me see here. Down below at C, which plan would I recommend? Well, I would say something to the effect of, due to the fact that in both Planet 1 and Plane 2, there is a 0.96 probability proportion of the individual being cured. Since it is the same, I would go with Plan 1 because it is $2 cheaper at $110 compared to $112. And you could kind of go into that. So that's why you would say what you would say on Part C. Again, showing a little bit more work, but that's the idea of where we would be at for this one. Okay? Number 3. Okay. Determine the probability of finding a pearl of the appropriate size in an oyster selected at random. Express this probability as a number between 0 and 1. All right. Trying to see just some key terms here. All right, it is normally distributed. Okay. The manager knows the pearl found in his oyster bed have diameters that are normally distributed with a mean of 8 and a standard deviation of 2. Okay. So he wants 2 pearls between 7 and 9. Okay. All right. Assume that every oyster contains 1 pearl. All right. So the manager wants to know how many oysters should expect to open to find 2 pearls of the appropriate size for this special order. Complete the following parts to design a simulation to answer the manager's question. All right, determine the probability of finding one pearl of the appropriate size in an oyster selected at random. So in this situation, this is a normal distribution where we have 8, 2, and this would be appropriate size would be between 7 and 9. So here's 8, 7, and 9. So we want to find the probability that goes here, and you can use normal CDF. Make sure you state the lower, comma, upper, comma, mean, comma, standard deviation, or you can do z-score. Okay, either one of those two would work on that, but make sure you express it there. B says determine how you would use, and it only says 1 pearl. If it said 2 pearls, then you would multiply that by itself. It'd be this and this, but it's only 1. This time he says describe how you would use a table of random digits to carry out a simulation to determine the number of oysters needed to find 2 pearls of the appropriate size. Include a description of what each of the digits 0 to 9 will represent. I believe this was 0.40 that was there. What that would mean would be that 40% of the time it's appropriate size. So a couple of things you need to know. First off, you would say each of the digits represents a specific oyster that is selected. Let's say that from 0 to 3, and again you would write this out, it would represent an oyster with I'm trying to see the context, with an appropriate sized pearl. Okay. 4 through 9 would be not a pearl that is appropriate size. Okay. Each digit is independent from the last, and you don't have to know numbers outside the range because 0 to 9 that's all numbers, so you're good there. And you actually don't even talk about repeats because each is independent from the next. Each one is not impacted by the previous one. And then so in this instance it said 2 pearls. So I'm going to, and then you have to say this, keep drawing oysters until 2 are found that have pearls of appropriate size. That have pearls of appropriate size. Again, I would include a little bit more, but this is a good thought here. The next thing you're going to do is you're going to go down to C. You're going to actually perform the simulation 3 times. So in my context, I would say 0 to 3, right? So I would say this is no, 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 yes, and yes, and I would stop there. That would be simulation number 1, okay? Simulation number 2 would be no, 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 yes, no, yes. That's simulation number 2. And 3 would be no, yes, no, 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 yes. And that'd be number 3. Okay. Again, you keep going until you get 2 pearls of appropriate size. Okay. All right. Nicely done. All right. Last but not least, the results of 2 100 trial simulations. One searching for 2 pearls between 7 and the other searching for 2 pearls between 4 and 6.5 are shown below. Identify which distribution represents the search for 2, 7 to 9 pearls. Let's see here. What I want to do, I want to show you this one. right, I'm going to show you this the answer here because I think this will make sense. You don't have to include all of this, but this would be something that would be good, or how you could approach it. So if the student computes the probability of finding a smaller pearl, this should be considered a bonus. If argued that a pearl between 7 and 9 is more likely because this interval contains the mean or is closer to the mean, then this is not a major error, but it's considered a minus. Okay. That you have to select A. If the student selects the distribution based on how well it matches their simulation, this is an acceptable approach. So up at the top, it says the probability of finding a pearl is smaller than the probability of finding a pearl between 7 and 9. Okay? And it therefore will take longer to find 2 pearls between 4 and 6.5. So as you look at this, it would take longer for the 4 and 6.5, okay? And therefore would be B, right? It would take longer than it would to find one between 7 and 9, right? Because if you think about it, when you look at the normal distribution, where this is 8, 4 to 7.5 would be more on this side, right? Whereas compared to 7 to 9, that would be more towards the middle, and this would have a higher probability than the have a higher probability of having less oysters than the one on part B. Okay. E says use the appropriate distribution in part D to compute an estimate of the expected number of oysters open to find 2 pearls in the diameter. Okay. Again, you're going to take the sum of the x values, and you'll see by estimating, we're just estimating this balance point. We'll use this formula 5.26, and again, you'll see the expected number of the sample mean is 5.16. 1 over 0.38, right, is kind of what we have here. We multiply that by 2. So yeah, so we're just looking at the sum of what our x values are multiplied by that probability divided by 100. And that's really what we're looking at in terms of part E there. If you have other questions on how that was solved for, so yeah, so to find, remember the expected value is like the mean, right? So if we could find what the probability of getting towards the mean would be, 1/38, 13 over my total selected, which was 100 trials, right? So I would, let me just scroll down here. I'm trying to explain it a little bit better. We multiply by 2 because that would be, we're looking for the probability of 2 of those occurring, right? So we would say 2.56 multiplied by 2, which would be 5.26, the balance point of that distribution. If you need more help on this, I don't like the way that I'm explaining this. Come on in for part E. That is a little tricky. I'd love to talk with you over that as well. Okay. Awesome. Well, hey, I appreciate it. Good job today, y'all. Good job, AP Stats team. Keep it rocking. See y'all. Bye.